Hi everyone. So today we're going to finish up with the theory on trig integrals. And then tomorrow we're going to do the last few examples before your tutorial quiz on Wednesday. Okay, so today we're going to look at integrals that look like this. So we have the integral of sine 4x cos 5x dx, something like this. So notice that we've got a 4x and we've got a 5x. Okay, so if it looks like this, we can't do a u substitution because we can't get from sine 4x to cos 5x. You see that the numbers in front of x are different. Okay, we can't do integration by parts because both functions are trig functions. So there's no way to make one of them simpler by either differentiating or integrating. Okay, and we can't use the trig integral identities that we've been looking at because of these arguments here of the 4x and the 5x. There's no way to write cos 5x in terms of sine x or sine 4x. So we can't do any substitutions like that. So we're going to have to do something different. So before we get onto this example, let's just look at our sum angle identities and minusing angles identities with sine and cosine. So we have sine A plus B. Okay, if we're taking the sine of two angles being added, we know that we can separate this out using an identity. So that's going to be sine A cos B plus cos A sine B. Yeah, we know we can write it out like this. And notice that on the right-hand side, this first term, the sine A cos B over there, that looks very similar to what we have in the integral. We've got sine 4x cos 5x. Okay, so if A is 4x and B is 5x, you see we've got something like that there. Now, if we take a look at sine A minus B, then we end up with something very similar, but with a minus sign. We get sine A cos B, same as before, but now we get a minus cos A sine B. Okay, so very similar to what we had before, but now we've got this minus sign. So what happens if we take these two expressions here and we add them? Okay, well, on the left-hand side, if we add them, we're going to end up with sine A plus B plus sine A minus B. And this is equal to sine A cos B plus sine A cos B is going to be 2 sine A cos B, and cos A sine B minus cos A sine B, that just cancels. So we're left with something like this. With a bit of rearranging, we end up with sine A cos B is equal to 1/2 sine A plus B plus sine A minus B. Okay, so we end up with something like this, which is a lot easier to deal with than this product of functions. So if you have sine A times sine B, you can separate it into two individual sine terms. Okay, which is a lot easier to work with. Okay, because since they're individual, you can integrate the first one and then integrate the second, okay, independently. Okay, so this is if you're dealing with something sine times cos. What happens if you're dealing with sine of something times sine of something else? Well, in that case, we can use a different trig identity, but not the sine identity. We can use the cos identity. So if we have cos of A minus B, we can write this as cos A, cos B, plus, so remember with the cos, if there's a minus on the left-hand side, then there's a plus on the right-hand side because it swaps. And then we have sine A, sine B. Yeah, that's what we want. We want something like this with sine times sine. Now let's look at the other identity with the plus sign. So we have cos A plus B is equal to cos A cos B. Now the plus becomes a minus, so we have minus sine A sine B. Again, that's what we wanted. We want a product of the sine functions. Okay, so we're going to take these two expressions, and now if we add them, then the sine terms are going to cancel. Okay, but we want to solve for the sine terms, so we're not going to add them, we're going to subtract them. So here we get cos A minus B minus cos A plus B is equal to, now since we're subtracting, the cos terms are going to go away, and then we're going to get sine A sine B minus sine A sine B, so that's going to become a plus. So it's going to become 2 sine A sine B. Okay, similar working to before. We just need to do a bit of rearranging. So we see we have sine A sine B is equal to 1/2 cos A minus B minus cos A plus B. Okay, so you see in this case, we got very similar to before. If you have a product of sine functions, sine A times sine B, we can separate them into two individual cos terms that you can then integrate. So you can integrate the cos A minus B, because that will be one term, and then the cos A plus B, that will also be one term. Okay, we don't have a product anymore. Okay. Okay, so what we need to do now is the last one is when we have cos times cos. Okay, so if we have cos times cos, what do we have to do? Well, we start off the same as before with our cos identity. So we have cos A minus B is equal to cos A cos B plus sine A sine B, and then cos A plus B is equal to cos A cos B, but now we've got the minus sign, sine A sine B. Okay, so what we want to do now is get rid of the sine terms, so we're going to have to add them. So if we add them together, we get cos A minus B plus cos A plus B is equal to, the sine terms are going to cancel each other, so we're left with 2 cos A cos B. Okay, and again with a little bit of rearranging, we end up with cos A cos B is equal to 1/2 cos A minus B plus cos A plus B. Okay, again, we've got our two individual terms that we can then integrate. Okay, so this is the method of solving for these products of trig functions. So let's just make a little summary of what we've done, and then we can use one of these to then solve our problem. Okay, this problem we've got here. So the sine times cos, we see that it's something like sine A times cos B. So we're going to use our first identity that we derived. Okay, but before we get to that, let's just do a little summary of the three identities. Okay, so number one, we have that sine A cos B. So this is when the two terms are different. So one of them is sine, one of them is cos. This is going to be equal to 1/2 sine A minus B. Okay, and then remember we added them, so then we have sine A plus B. Okay, so that's if they're different. So you have one sine term times another cos term. Okay, the next case is if they're both the same, and more specifically, they're both sine terms. So we have sine A times sine B. In this case, we're going to have 1/2 cos A minus B, and then we had minus cos A, that's an A plus B. Okay, so that's if we're dealing with two sine terms being multiplied. And lastly, the final case is if the two terms are both cos. So we're going to have something like cos A, cos B. Okay, very similar to what we have above. It's going to be 1/2 cos A minus B. But remember, there was that minus sign difference, so we now have plus cos A plus B. Okay, so these are the three identities that we need to know, and these cover all of the cases. So if you have something like sine 4x cos 5x, that's a sine term times a cos term, so you would use case 1. Okay, where you have sine times cos. If both terms are sine, you would use case 2. If both terms are cos, you would use case 3. Okay, so that's a little summary of the three things that you need to know. Okay, let's take a look at this example we had at the beginning. So we had sine 4x cos 5x. So we said that was case 1. Okay, so let's try and solve that. So we have the integral of sine 4x cos 5x dx. Okay, we said that was case 1. So we're going to have to expand this out using the identity for case 1. So we've got the half. We can take that to the outside. Integral sine A minus B. So that's going to be sine of 4x minus 5x. Plus sine of A plus B. So that's going to be 4x plus 5x dx. Now inside the brackets are just x terms, so we can add them together or subtract them. So we're going to have 1/2 the integral of 4x minus 5x is minus x. So we're going to have sine of minus x plus sine 4x plus 5x. So that's going to be sine of 9x dx. Okay, so that's 1/2 the integral. Now sine of minus x, that's the same thing as minus sine of x. So we can take the minus outside. And sine of 9x, that stays the same. Okay, so now we can integrate. So the integral of sine is minus cosine, and the minus are going to cancel. So we're just left with cos x. Okay, and then the integral of sine, remember that's minus cosine, so we have minus, but also we've got this factor of 9 in front. So remember, if we're differentiating, we multiply by that factor. If we're integrating, we have to do the opposite, so we divide by that factor. So it's 1/9 cos 9x. So the sign has to change to a cos. Okay, and don't forget, this is an indefinite integral, so we always have to add our plus c. Okay, so that's how we take care of these types of problems. So if you have something like sine 4x times cos 5x, you just need to identify we've got a sine term times a cos term. Okay, so we know which identity to write that as. So that would be the sine A minus B plus sine A plus B. Then you just look at what your A and B are. So your A is 4x, your B is 5x. You simplify the arguments so that it's a single x term. So in this case, minus x and 9x. Okay, and then you can just integrate those as you would normally. Okay, let's look at one more example, and then I'll save the rest for tomorrow. Okay, so let's say we have the integral of sine 2x times cos 3x. Let's change this. Let's make it we've already done sine times cos. Let's do sine times sine. Okay, so we've got a product of two sine terms. So this is something like sine A, sine B. Okay, we need to figure out that. So this becomes the integral of, so we've got a sine times a sine. Let's see what that goes to. So sine times a sine, that's case 2. It's going to be cos the first bit minus the second bit, so A minus B, minus and then A plus B. Okay, and they're both cos. So it's going to be 1/2, then cos. Okay, so now we need to look at what our A and B are. So it's going to be cos of A minus B. So it's going to be cos of 2x minus 3x. Okay, because this first bit here is A, the second bit here is B. Okay, so the first bit here is A, the second bit here is B. Okay, then we had the minus sign. So it's going to be minus. And then the same thing with cos, but now we have A plus B. So it's going to be 2x plus 3x dx. Okay, so what we need to do now is simplify the brackets there and then integrate each term separately. So we're going to have 1/2 the integral of cos 2x minus 3x. That's going to be minus x minus cos 2x plus 3x. That's going to be 5x dx. Yes, that's 1/2 the integral. Cos of minus x is just cos of x. So we can write this as cos of x. And cos of 5x, we can't simplify that anymore. So that's just cos 5x dx. Okay, so now we can do the integral on each term individually. So we have 1/2 on the outside. The integral of cos is going to be sine. So we have sine x. Again, the integral of cos is sine, but we've got this factor of 5. So that's going to be minus 1/5 sine 5x. Okay, and again, this is an indefinite integral like we had before. So we need to have the plus c. Okay, so that's just another example with something like sine times sine. Okay, so you see they're not too bad as long as you can identify which type it is. So you can have type 1 with the sine times a cos, type 2 with the sine times a sine, or type 3 with the cos times a cos. Now remember that there's no squared terms or cubed terms. If you have stuff like that, you use the methods we discussed before. So this is just sine by itself. However, the argument could be some multiple of x, so sine 3x or sine 4x. Okay, you can't do sine squared 4x. That's going to have to use the previous methods. Okay, so you just identify which type it is, you figure out which bit is A, which bit is B, and then rewrite your left-hand side using the identity on the right-hand side. Okay, once you've done that, you just simplify the brackets. So your a minus b, you simplify that. Your a plus b, you simplify that. Integrate your two terms, and then any last bit of simplification, you do that. And then remember to add your plus c. Okay, so it's an indefinite integral. You add your plus c. Okay, if you do have any questions on this, please let me know on the WhatsApp group. Remember, we also have the tutors available. You can ask them for help, or you could email me and then I can get back to you on that. Okay, so tomorrow we're going to be going over a few more examples on this. Okay, just to solidify our understanding of that. So that would be Tuesday. And then on Wednesday, we have the summative tutorial quiz. So remember, if it's summative, you're going to have to write out your answers, scan it, and then submit. Okay, we've got 3 questions for Wednesday. Each of them is 5 marks. So that's a total of 15 marks for the quiz. Okay, they're very straightforward questions, exactly the same as what we've gone over for trig integrals. Okay, but you do have the full 1 hour to complete it. Okay, so please take your time going through it. Look up stuff if you need to. Just, get some practice with the quiz, because we do have the test coming up on the 11th of May, test 3. Okay, and you're going to have 1 section in test 3 on the trig integrals. Okay, so it's good to get your practice now. Okay, but like I said, if you do have any questions, please let me know on the WhatsApp group or through email. And then tomorrow we'll go through some more examples. Okay, so I'll see you then.